So, welcome to the one more session today. So, last session we completed solid waste management. So, before we go into the details of air pollution and control, as usual, let us see some information related to Unacademy. So, Unacademy is giving 23% discount, flat 23% discount on the New Year Eve for all subscriptions. So you can use my code GATE Civil. Okay, avail this offer. Conducting mock exams free of cost. Enroll for January 8, 15, 22, 29. So you can use code GATE Civil. Okay, let us start today's session. Last topic in GATE syllabus. Noise pollution is removed from the syllabus. Air pollution and control. We already discussed that human beings consume. Human beings, air intake is more for human beings compared to food intake and water intake. So on average we breathe 22,000 times to 25,000 is 25,000 times in a day. For every breath we take 2 to 6 liters of air. So so much amount of air get into our body. And not only that, the air we breathe that has got direct contact with the sensitive organs of human body. So therefore, the quality of health, the health of human beings depends on the quality of air that we breathe. Okay, if air is polluted, and that affect our health also. So therefore, there is a concern about air pollution. So we all know that these air pollution problems are not like water pollution problems and other problems. Water pollution problems, you can see that whether water is good or bad, but air is not like that. You can't notice which is good air, which is bad air. You can't see the air, you can only feel it. Therefore, before you realize which is good air, which is bad air, the damage happens. So therefore, we're supposed to be careful. Corona happening now. Corona also, the 2 years back, they declared it as a airborne disease. Okay, it travel through air. From it is infected from one person to another person by traveling through air. Okay, so exactly like that, so many number of contaminants present in air, they affect our life. So we need to deal with them. So here I concentrate on numericals, examination point of view. So presence of one or more air contaminants. In ambient atmosphere of such nature, of such duration, to be or threatened to be injurious to human life, plant life, animal life, and as well as damage the property. Presence of one or more air contaminants in ambient atmosphere. To be or threatened to be injurious to human life, plant life. Plants also get affected due to air pollution. Animal life, okay, and as well as to the property. And even damage the property. It's known as air pollution. Okay. So if you see the composition of air, air is nothing but a mixture of gases. It is a mixture of gases. The major gases of air are one, nitrogen, oxygen, argon, and carbon dioxide. These are the major ones. Carbon dioxide support plant life, oxygen support human life and animal life. So human beings and animals survive due to oxygen. Carbon dioxide support plant life. So the life sustaining resources are present in air. So nitrogen is present in 78.09% is nitrogen. 20.95% of air is almost 21% is oxygen. Argon is 0.93% and carbon dioxide is 0.032%. And remaining gases in traces. So many remaining gases are there. So many are there. Hundreds of gases present. But they are present in small amounts, traces. Okay. And if you see this air is filled in the atmosphere. Atmosphere is filled with air. If you see the structure of atmosphere, the atmosphere is divided into 4 distinct zones. Atmosphere means the space above the ground. Space above ground is known as atmosphere, filled with air. That's the reason why we need to talk about atmosphere. Atmosphere is divided into 4 distinct zones. What are they? You all know that. What are they? 1. Troposphere. 2. Stratosphere. 3. mesosphere, 4 ionosphere or thermosphere. Recently they found one more, exosphere, but yet to get into academics. So 0 to 12 kilometers approximately above ground, you'll find troposphere. The 12 to 52 kilometers above ground, you find stratosphere. 52 to 90 kilometers above ground, you'll find mesosphere. Greater than 90 kilometers, you'll find ionosphere or thermosphere. Okay? So this divided into 4 distinct zones purely based on temperature profile of atmosphere. So the atmosphere is divided into 4 distinct zones based on temperature changes. And if you make a plot, temperature versus altitude, altitude means height, Z versus T plot, then 0 to 12 kilometers, things will be different. Okay, approximately I am plotting, not exactly to the true scale. Assume 0 to 12 kilometers, 12 to 52 kilometers, things will be different. 52 to 90 kilometers, things are different. Above 90, things are different. So this is called troposphere, this is strato, this is meso, on the top of it ionosphere. This is purely based on temperature changes. In troposphere, temperature decreases with altitude. In stratosphere, again temperature increases with altitude. Mesosphere, again temperature decreases with altitude. Ionosphere, again temperature increases with altitude. So this is purely based on temperature profile, temperature changes. Okay? Troposphere, temperature decreases with altitude. Stratosphere, again it increases. Mesosphere, again decreases. Ionosphere, again increases. This is purely based on temperature profile of vertical atmosphere, not based on height. It is temperature changes, because that plays an important role in concentration of air pollutants in atmosphere. Okay, then what kind of air contaminants we can notice? Sources of air pollution, and this and all not required truly speaking. Or classification of air pollutants. Air pollutants present in atmosphere are classified into, this much is known more than sufficient. One is primary air pollutant, and second is secondary air pollutants. Primary air pollutants means pollutant released into atmosphere in one form, remain in same form, then it's called primary pollutants. Pollutant released in one form, remain in same form. Released from where? From ground only we release. Pollutant released from ground into atmosphere in one form and remain in atmosphere in same form, then it's called primary air pollutant. Atmosphere are known as primary air pollutants. The major primary air pollutants are, right, carbon monoxide, oxides of sulfur, SOx they are called, oxides of nitrogen, right, particulates, etc., particulate matter. Then similarly, secondary air pollutants. Pollutant released in one form and remain in different form in atmosphere are known as secondary air pollutants. Okay, pollutant released in one form and remain in atmosphere in different form. So it changes in atmosphere. They're asking this question in exam are known as secondary air pollutants. Okay. The very popular secondary air pollutants are ozone. Ozone in atmosphere is a secondary air pollutant found by photochemical reactions in atmosphere. Then peroxyacetyl nitrate (PAN), peroxybutyl nitrate, peroxypropanol nitrate. Anything start with P letter is by default it is secondary air pollutant. Peroxyacetyl nitrate, peroxybutyl nitrate, peroxypropanol nitrate. Then smog, atmospheric smog. Smog means what? Smoke plus fog. So smoke released into atmosphere react with substance present in atmosphere converted altogether into different kind of pollutant in atmosphere known as smog. Every year London so many people die due to smog. Okay. So very popular pollutant that is. So like primary citizen, secondary citizen. Primary citizen means what? The person born in one country and remain in same country, then he is a primary citizen of that country. The person born in one country, live in different country, then he is called as a secondary citizen. Okay. Students going to America and all, they are treated as secondary citizens. Whereas the person who born in America, remain in America, study in America, do job in America, they are called primary citizen of America. So a person who born in India, after education, go to America and do the job, software job or some job, okay, or do MS and settle down in America, then he is treated as a secondary citizen to that country. Okay. So he born in India and after going there, and he become as an American. So born as an Indian, remain as Indian. So like me, the person who born in India, remain in India, primary citizen always. So exactly like that. Okay. This is one question they are asking. Then based on state of matter of air pollutants, based on state of matter of air pollutants, they are classified into two categories. One is particulates, other one is gases. Particulates again, either they are in solid form or they are in liquid form. Solid particulates are, example is dust particle. Liquid particulate example is mist particle in atmosphere. Remaining all are gases, carbon monoxide, SOx, NOx, etc. Gaseous air contaminants. Particulates, they are either they are in solid form or in liquid form. They are remain in atmosphere. Gases are, most of the contaminants are in gaseous form only. This also you remember. Okay. Next, this and all okay. The first numerical question what you can expect is how concentration of air contaminants are expressed, and they are asking the unit conversions given in one unit system and you are expected to work out in different unit system. So concentration of air pollutants. So concentration of air pollutants present in atmosphere are continuously monitored. We monitor them. There is one department is there, their job is measuring their concentrations only. That's called pollution control board. Okay, there's a department called pollution control board. Their duty is find out concentration of different pollutants in atmosphere, continuously monitored, measured, and expressed in terms of microgram per meter cube or ppm or ppb. ppm means parts per million, ppb means parts per billion. So conversion is asking. Conversion is not that simple and easy, because in water, for water or wastewater or for liquids in general, we took 1 milligram per liter is equal to 1 ppm. That is true. But that is true only for liquids. For gases, right, 1 milligram per liter is not equal to 1 ppm. That is different. So conversion will ask you microgram per meter cube will give you, ask you to express in ppm, or ppm they will give you, and you are expected to work out in microgram per meter cube. So you have to learn that technique, how to convert. Okay. So gases, they expand. They are compressed and they expand. So their volume keep on changes. Their volume depends on their compressed, their expansion, their compression depends on what? Temperature and pressure. So concentration of gaseous air contaminants in atmosphere gaseous air contaminants in atmosphere. Okay, how I am writing this is not required. So let us, I'll give you how to convert microgram per meter cube to ppm, ppm to micrograms. Okay. Microgram, ppm to microgram per meter cube and microgram per meter cube to ppm, how they are converted. So this is very popular question in GATE exam. This question they keep on asking continuously in GATE exam. Okay. So x ppm of any gaseous contaminant in atmosphere is equal to x into m by k into 10 cube microgram per meter cube. That's all. And x microgram per meter cube of any substance, how to express in ppm? X into k by m into 10 cube ppm. Okay, that's how we can. X could be anything. It could be carbon monoxide, or it could be sulfur dioxide, or it could be nitrogen oxide, anything, any gaseous contaminant. X is any gaseous air contaminant. Okay, or X is amount of gaseous contaminant, whatever it may be. So the two things you need to know, what is M? M is equal to molecular weight of any gas whose concentration is to be found. Okay, then K is a constant. This K value we work out by RT by P into 10 cube. Our R value also not given. This is taken as 82.05. Sorry. (82.05) into, actually R value is 82.05 into 10 power minus 6. Right? Units of this is into T by P. Sir, otherwise you can take this. 10 power minus 3 into T by P. Okay, if R value is not given, where T is substituted, temperature in degree Kelvin. This should be substituted temperature in degree Kelvin. P is equal to pressure in atmosphere. In which unit system I have to measure? Atmosphere. So R value, in this R value is nothing but a universal gas constant. R is universal gas constant. And whose value is equal to 82.05 into 10 power minus 6 atmosphere meter cube mole Kelvin. Okay, this R is universal gas constant. Its value is equal to 82.05 into 10 power minus 6 atmosphere meter cube by mole Kelvin. That's the unit of R. Usually they will give, they don't give, then you can take 82.05 and 10 power minus 3. So K value out work out R into T by P. So given temperature and pressure, concentration depends on temperature pressure. So temperature pressure are very important. How much volume that gas occupy depends on temperature and pressure. Okay, therefore they should be given. And vice versa. Vice versa means what? It is ppb given. Understood? No, this is. Okay. If it is given in ppb, ppb to microgram per meter cube. ppb means parts per billion. Microgram per meter cube to ppb. So in this case, x ppb of any substance is equal to x into same m by k microgram per meter cube, and x microgram per meter cube of any substance is equal to x into k by m ppm. So where k stands for same, it is RT by P into 10 cube, or otherwise 82.05 into 10 power minus 3 into T by P, where T is equal to temperature in degree Kelvin, P is equal to pressure in atmosphere. So based on this, is keep on asking questions in the exam. Just remember this shortcut and work out. Where M stands for same molecular weight of any gas. Sorry, ppb it is. Okay. M is same molecular weight of any gaseous contaminant for which a conversion is required. Shall we go ahead with the solving problems? Okay. Let us take one GATE question. Question number 1. Express 200 microgram per meter cube of sulfur dioxide in ppm and ppb at STP. This was the question. STP means what? Standard temperature and pressure. Standard temperature and pressure. Okay. Standard temperature is 0 degrees Celsius. Pressure is 1 atmosphere. 0 degrees Celsius means, how to convert this into Kelvin, plus 273. So 273 degree Kelvin. Then R value is not given. We have to work out. So K value, R value, M value. So M value is equal to molecular weight of sulfur dioxide, molecular weight of SO2. So S plus 2 into O, 32 plus 2 into 16, 32, it is 64, M value. Okay. Then what else you need to work out? K value. K value is RT by P, R into 10 cube, or otherwise 82.05 into 10 power minus 3 into T by P. So R value is not given anyway. So I'll work out this value at a standard temperature and pressure, which is equal to 82.05 into 10 power minus 3 into 273. It is 22.4. Okay, 22.399 I got. So I round it to 22.4. 22.399 rounded to 22.4. That's all. So only two things you have to work out: M value, K value. M value we got 64, K value this much. Next, formula substitution only. Microgram to ppm. Okay. So 200 microgram per meter cube of SO2 is equal to how many ppm? So 200 into K by M into 10 cube ppm this is. So 200 into K value we got just now 22.4, M 64 into 10 cube ppm. That was the answer for this question. Simplify, we will get this. Come on, work out 200 into 22.4 divided by 64 into 10 cube. So it is 0.07 ppm. That was the answer for this question. Understood? Similarly, ppb, 200 microgram per meter cube of SO2 is equal to 200 into K by M ppb. So 200 into K value is 22.4, M value is 64 ppb. That's all. That is the answer. So simple it is. So 200 into 22.4 by 64. How many ppb? 70. 70 parts per billion. Oh. $70 only, no? 22.4 into 200 divided by 64. 70 ppb. Parts per billion, 70 parts in billion parts. Million parts 0.07, in billion parts it is 70. Same thing, same concentration. That is how we work out. Understood? Now let us take one GATE question. This question is been asked in the year GATE 2006. Question is the mean indoor airborne chloroform concentration. The mean indoor airborne chloroform concentration. Chloroform concentration, chloroform formula also given, CHCl3, brackets he has given. GATE question, no, this is with crystal clear clarity you will find question. Chloroform concentration in a room was determined to be 0.4 microgram per meter cube. Use the following data. T is equal to 293 degree Kelvin, P is equal to 1 atmosphere, and R is equal to 82.05 into 10 power minus 6 atmosphere meter cube by mole Kelvin, the unit of R, that is. And atomic weights of C is equal to 12, H is equal to 1, Cl is equal to 35.5. Is a gate question, crystal clear information is given. This concentration expressed in parts per billion is equal to, so options given, 1 ppb, B, 0.2 ppb, C. You need not write ppb again. You can give. He has given like this, but I am removing 1 B because he has given ppb in the question only. 2.2 C, 0.1 D, 0.08. Come on, work out. Try this question. Come on, try. So very simple it is. What is M value? M is equal to molecular weight of CHCl3. So C plus H plus 3 into Cl. Come on, work out. 12 plus 1 plus 3 into 35.5. That is M value. Come on, how much? What is M value? So that 3 into 35.5 plus 12 plus 1. So it is 119.5. That is M value. Then K value. What is K? So it is RT by P into 10 Q. So R is given in the question. So 82.05 into 10 power minus 6. Temperature is given. How much is given? 0. Temperature is given here. 293 degree Kelvin. He has given in degree Kelvin only, none of any conversion, into 10 cube. That is K value. So 82.05 into 10 power minus 6 into 293 into 1000. It is 24.04. So K value we got this. That's all. What is given? 0.4 microgram per meter. So 0.4 microgram per meter cube of CHCl3 is equivalent to 2. It is 0.4 into, or my chloroform, otherwise you can write How many ppb is asking? Chloroform is equal to how many ppb? So 0.4 into ppb, no? So it is K by M ppb. So it is equal to 0.4 into K value we got 24.05, M value 119.5 ppb. Come on, what is the answer? So 0.4 into 24.04 by 119.5. So it is 0.08 ppb. That was the answer for this question. So which option matching there? D option matching there. So that is how we need to work out. This question is very, very popular. They keep on asking this question in GATE exam, especially conversions, because normally what we do, 1 ppm is equal to 1 milligram per liter. So we convert milligram to micrograms, liters to meter cube. Like that you work out. Then we will go wrong. That is not correct. That is true for water, not for air. Okay. Let us try one more question. This question has been asked in GATE 2015. Same question. Example 3. GATE 2015 question. The concentration of sulfur dioxide in ambient atmosphere was measured as 30 microgram per meter cube. Under the same conditions, the SO2 concentration expressed in ppm is dash. That was the question. Given, this data is given. P by RT value given straight away, 41.6 mole per meter cube. Where P is pressure, T is temperature, we know that R is universal constant, molecular weight of SO2 also given. This is also given. Come on, work out, all of you. Easier than last question. So what we require? M is given. M is equal to 64 and K value is equal to, it is RT by P into 10 cube. Okay, but what is given? P by RT is given. Therefore RT by P is equal to 1 by 41.6. So K value is equal to RT by P into 10 cube. So 1 by 41.6 into 10 cube. That is K value. So 1000 by 41.6. So it is 24.04. 24.038, nothing but 24.04. Rounded to 24.04. That is K value. K value we got, M value is known. Can't work out. Concentration. So 30 microgram per meter cube of SO2 is equal to, it is 30 into K by m into 10 cube ppm. So 30 into K value is 24.04. M is 64 into 10 cube ppm. That was the answer. So 30 into 24.04 by 64 into 1000. So it is 0.01126 ppm. That was the answer. Try this question. Work out this question, all of you. So express (31.356) into 10 power minus 3. ppm of NO2 in terms of microgram per meter cube at temperature 20 degrees Celsius and pressure 202.8 kilopascals. Take R is equal to 82.05 into 10 power minus 6 atmosphere meter cube by mole Kelvin. Come on, work out. So now this question is solved, then I'll appreciate you. Come on, Ankit Kumar. Are you there? You disappeared. So you have to know how to convert kilopascals to atmosphere. That's the trick here. How to convert temperatures to degree Kelvin. So temperature in degree Kelvin is equal to temperature in degree Celsius plus 273. So therefore it is 20 plus 273 is equal to 293 degree Kelvin. That is first question. Second is pressure. One atmosphere is equal to 101.4 kilopascals. So pressure given here 202.8 kilopascals. Then how many atmospheres it is? 2 atmospheres. Since 1 atmosphere is equal to 202 kilopascals, so he has given 2 atmospheres. Then you can work out. So M is equal to molecular weight of NO2. N is 14 plus 2 into 16, 32. 32 plus 16, 46. And K is equal to, it is RT by P into 10 cube. So R is 82.05 into 10 power minus 6 into 293 by 2. Come on, work out. 82.05 into 10 power minus 6 into 293 by 2 into 1000. It is 12.02. So we got K value, we got M value. Next conversion. So what is given there? 31.356. So 31.356 into 10 power minus 3 ppm is equal to 31.356 into ppm of which gas? NO2. NO2 is equal to 31.356 into 10 power minus 3 into, right? It is M by K into 10 cube ppm. No, sorry, microgram per meter cube. So 31.356 into 10 power minus 3, M is 46, K is 12.02 into 10 cube. Come on, how many microgram per meter cube it is? So 31.356 to 10 minus 3 into 46 into 1000 divided by 12.02. So it is 199.99. So rounded to 120 microgram per meter cube. That was the answer. Understood? So this is how we work out numericals related to conversions. So unit system, civil engineers generally they are good at subject but poor at unit system. Therefore, we try to exploit maximum. Okay then, next. The major air pollutants of concern in air quality studies are one is particulates, two is carbon monoxide, three is SOx, four is NOx. These four. Particulates are nothing but people also call them as suspended particulate matter SPM. SPM or TSP. SPM means suspended particulate matter. Like suspended particles. TSP means total suspended particles. They are suspended only, suspended particles only. So they are present either in liquid form or solid form. So particulates of concern in air quality studies usually range. Particulates of size 0.01 micron to 100 micron are dangerous air contaminants. These particulates cause contaminants cause, right, bronchial diseases like respiratory diseases. Respiratory diseases to humans. such as asthma, bronchitis, etc. Okay, that's why we concern about. So we measure these particulates in atmosphere by high volume air sampler. So based on high volume air sampler experiment, they are asking questions in GATE exam. Particulates in ambient atmosphere. Measured by high volume air sampler using filter paper. Suspended particles any medium we measure by filter paper only. So after measuring with high volume air sampler, we work out suspended particulate matter or total suspended particulates in microgram per meter cube is equal to, we work out in microgram per meter cube. Okay. So final weight of filter paper minus initial weight of filter paper by volume of air sampled. So WF is final weight of filter paper. Filter paper we use. Specially made filter paper we use. Initial weight of filter paper. So we pass known volume of air sample through filter paper. If air sample contains particulate matter, that particulates are retained by filter paper because it contains pore spaces. Those pore spaces are smaller than the smallest particulate present in air. Therefore, they are too large to pass through small pore spaces. They are retained. Okay. So volume of air sample is equal to, so rate of sampling, nothing but air flow rate through high volume air sampler, nothing but pumping rate of air. So air is pumped through high volume air sampler passing through filter paper. That's called air flow rate or into duration of sampling. People also call it as rate of sampling or rate of pumping. Rate of air pumping. Okay, that's how we can work out air flow rate through high volume air sampler into duration of sampling. So based on this one question in GATE exam they've asked, so we need to work out this equation based on this equation. In water also we work out in same fashion. Instead of volume of air sample, there you will find volume of water tested. That's it. So let us see that GATE question. Air pollution topic is little lengthy topic, so it will take 2 sessions. 2 sessions are required to cover all numericals, especially numerical part. Numerical part is important. So tomorrow possibly I'll complete your syllabus, and day after tomorrow quick revision. Quick means micro revision. So all in one day we'll finish up complete top to bottom, like population forecasting to air pollution. Again we cover once again all important things we'll write down. Okay. Right. Let us try this question. This question is been asked in GATE 2011. Total, I'll write TSP. Total suspended particulates concentration in, he has given GATE exam this question. In ambient atmosphere measured using a high volume sampler or ambient air. He has given air is to be measured using high volume air sampler. Whatever it may be. The filter used for this purpose had initial dry weight of 9.787 grams. The filter used, filter paper, for this purpose had an initial dry weight 9.787 grams. The filter was mounted in the sampler and initial airflow rate through the filter set at 1.5 meter cube per minute. Sampling continued for 24 hours. 24 hours, air is passed through filter paper. That's what the meaning. 24 hours, the airflow after 24 hours was measured to be 1.4 meter cube per minute. The dry weight of filter paper after 24 hours sampling was 10.283 grams. This and all not required description and all. What is initial weight, what is final weight, that's all. Assuming linear decline, in the airflow rate during sampling. What is 24 hours average TSP concentration in ambient air? That was the question. Options are given. A 59.2 microgram per meter cube, B 118.6 microgram per meter cube, C 237.5 microgram per meter cube, D 574.4 microgram per meter. Come on, work out. So simple, so easy. What is initial weight, what is final weight? That is important. So what is given? Simple. Question length is this much. Solution is so simple. So initial weight is equal to 9.787 grams. Final weight is given as 10.283 grams. Right? Duration of sampling is 24 hours. So volume of air sampled is it is declining linearly. So therefore I will take average airflow rate into duration of sampling. It is not maintaining constant throughout sampling. It is changing linearly. Therefore I force it to take average. Average airflow rate is 1.5 in the beginning. At the end it is 1.4. So average airflow rate is 1.4 into duration of sampling is 24 multiplied by 60. Because this is in meter cube per minute. This is also substituted in minutes, this value. Therefore minutes get cancelled. You left with a meter cube. So and so meter cube will get airflow rate. So and so meter cube will get. That's all. So TSP concentration is equal to W final minus W initial by volume of air sampled. So 10.283 minus 9.787 by 1.5 plus 1.4 by 2 into 24 into 60. So this is in grams, this is in meter cube. You will get gram per meter cube, but I have to work out in micrograms. Multiply 1 microgram is equal to 10 power 6 gram. 1 gram is equal to 10 power 6 micrograms. 1 gram is equal to 10 power 6 micrograms. So multiply with the 10 power 6, you will get microgram per meter. That's it. So 10 power 283 minus 9.787 by 1.5 plus 1.4, 2.9, 2.9 by 2. 2.9 means 1.45, that is. 1.45 into 24 into 60. Correct only, no, this is. Into 10 power 6. See, 237.5. 54 I got 237.54 microgram per meter cube. So which option matching? This matching. So that is how we can work out this one. Okay. Very good, Ankit Kumar. Next, carbon monoxide. If present in high concentration, carbon monoxide if present in ambient air in high concentration, cause high concentration is a dangerous air contaminant. Is a dangerous air contaminant. Small amounts present, no problem. So carbon monoxide react with hemoglobin of the blood and form carboxyhemoglobin. This carboxyhemoglobin is called asphyxia. If you inhale carbon monoxide once it get into your body, this react with hemoglobin of the blood. So instead of oxygen, it react with hemoglobin. Hemoglobin react with carbon monoxide and blood is contaminated with carboxyhemoglobin. So carboxyhemoglobin is asphyxiant. It is a cumulative toxin. A toxic substance it is. Cause asphyxia. Asphyxia means breathlessness which leads to death. Like corona patients, how they are dying? So they are finding difficult to breathe. After some time they will die. Exactly how corona patients die when they are severely attacked by corona. They get respiratory lungs problem. Lungs are infected, so they can't breathe properly. So same way, the breathlessness caused by carbon monoxide, asphyxia, which will ultimately result into death only. So carbon monoxide measured by NDIR analyzer. So non-dispersive infrared analyzer. NDIR stands for non-dispersive infrared analyzer. So one question let us solve related to this. This question has been asked in ESE exam. Example 6. ESE question this is. ESE 99. Okay, year not required. If a carbon monoxide is released at the rate of 0.03 meter cube per minute from a gasoline engine. Gasoline engine means exhaust pipe of your bike or a car. Gasoline engine, and 50 ppm is the threshold limit. Threshold means standard. It should not exceed more than 50 ppm. Threshold limit for an 8-hour exposure. So public exposed to this beyond 50 ppm, dangerous it is. The quantity of air which dilutes. So that smoke released from gasoline engine contain carbon monoxide which dilutes with air. The quantity of air which dilutes the contaminant. So concentration decreases, it dilutes contaminants to a safe level will be. What is safe level? 50. Threshold is 50, not more than 50. Should be less than 50 or 50 to a safe level. How much air will be required to keep that threshold limit? Will be options given are 60 cubic meter per minute, B is 600 cubic meter per minute, C is 60 meter cube per second, and D is 600 meter cube per second. So this is in meter cube per minute only. Come on, work out. Okay. So if you know definition of ppm, you can answer. Exactly 50 ppm to maintain 50 ppm of carbon monoxide means what? 50 parts of carbon monoxide in 10 power 6 parts of air. So air to carbon monoxide is how much you have to maintain? 50 by 10 power 6. Carbon monoxide to air ratio, how much you have to maintain? 50 by 10 power 6 to maintain 50 ppm. Understood? That's all. From this you can work out. Simple. 50 ppm. So Q carbon monoxide by Q air is equal to 50 by 10 power 6. So from this you can find out at what rate airflow rate should be there in atmosphere to maintain. Q carbon monoxide is given as 0.03 meter cube per minute. Q air is unknown. This is equal to 50 by 10 power 6. So from this you can find out Q air. So 0.03 into 10 power 6 by 50 meter cube per minute only will get. Or you can, if your answer doesn't match with the given options, we'll work out in meter cube per second. So how much air should be there in atmosphere? 600 cubic meter per minute airflow rate. Then that 50 ppm carbon monoxide concentration we can maintain if we release 0.03 cubic meter per minute of carbon monoxide into atmosphere. That was the answer. Okay. Next contaminant is SOx. SOx means oxides of sulfur. So among all oxides of sulfur, sulfur dioxide is dangerous air contaminant. It is a respiratory irritant to human beings. It is a respiratory irritant. It also affects plant life by causing plant diseases. Okay, so dangerous air contaminant, and most of SOx released into atmosphere from thermal power stations and oil refineries. Most of SO2 emissions are from thermal power stations by burning coal. Okay, and oil refineries, BPCL, HPCL. We are getting crude oil from Russia now. Crude oil they said that we refine and sell to the market, petrol, diesel and all. So from there we'll get so much amount of SO2. So let us see what question related to SO2. We are called common sense kind of questions, okay? One GATE question is there. GATE exam they ask that question. It's also common sense kind of question. GATE 2018 this is. Example 7. A coal containing 2% sulfur is burned completely to ash. In a brick kiln at a rate of 30 kilograms per minute. The sulfur content in the ash was found to be 6% of the initial amount of sulfur present in the coal fed to the brick kiln. This and all matter he has given. Okay. Then the molecular weight of S and O are 32. Is also given. Molecular weight of S and O are 32 and 16 gram mole respectively. The annual rate of sulfur dioxide emission. The annual rate of sulfur dioxide emission from the kiln in tons per year is dash. 2 marks question this is. Can work out. Read and work out. Simple. So rate of coal consumption is given. Rate of coal burning otherwise. So when you burn coal, that releases sulfur dioxide. Where in the kiln? 30 kilograms per minute. So percentage sulfur in coal is equal to 2. So rate of sulfur emission. Total sulfur emission. How much sulfur is emitted from coal? So 2 by 100 into 30 kilogram per minute. So sulfur trapped in ash. Sulfur in ash is equal to 6%. Remaining escape as gas. So gaseous sulfur emission is equal to percentage sulfur escape as gas is equal to 100 minus percentage sulfur trapped in ash. So 100 minus 6. If this is not given, 100% escape as gas, we assume like that, 94%. So therefore, sulfur gas emission rate is equal to sulfur gas emission rate is equal to 94% of this one, 2 by 100 into 30. Out of total sulfur, 94% is gas. So we are calculating gaseous contaminant only. Kilogram per minute. Per year, how much it is? 94 by 100 into 2 by 100 into 30 kilogram per minute. Minutes convert into, first let us convert kilograms into tons. Into 1 by 1000, then tons per minute. How to convert minutes into years? 1 minute is equal to how many years? 1 by 365 into 24 into 60. This is tons per year. 1 year is equal to 365 into 24 into 60 minutes. Therefore 1 minute is equal to 1 by 365 into 24 into 60 years. Understood? That's how we converted. So how much it is? Thousand no, kilograms to tons, 1000 this is. So 296.43 tons per year. But he's not asking sulfur, he's asking sulfur dioxide. Sulfur react with oxygen and produce sulfur dioxide. How to link between sulfur and sulfur dioxide? Using their molecular weights. So molecular weight of sulfur is 32. So molecular weight of SO2 is 32 plus 2 into 16, 64. That means 32 parts of sulfur is equal to 64 parts of SO2. 32 parts of sulfur react with 32 parts of O2 and produces 64 parts of sulfur dioxide. That's the meaning. 64 parts of SO2. Therefore, 1 part of sulfur is equal to 64 by 32 parts of sulfur dioxide. Then how much sulfur is produced? 296.43. So 296.43 tons per year of sulfur is equal to how many tons per year of sulfur dioxide? Tons per year of sulfur dioxide. Therefore, sulfur dioxide gas emission rate is equal to, so it is double, just double. 592.87 or 86 tons per year. That was the answer for this question. Suppose not mentioned, 6% is not trapped in ash, then 100% escape as gas. That's how we work out. Understood this question? Those who are watching? Okay. Then last parameter is NOx. Among all NOx, NO and NO2 are dangerous air contaminant. NO and NO2. Alveoli of humans sensitive to this. Human lungs sensitive to NO2 or sensitive to NOx in general. Okay, and NOx also affect plant life. And cause plant diseases. So many secondary air pollutants are produced due to NO2. By photochemical reactions in atmosphere. With NO2. Ozone, peroxyacetyl nitrate, peroxypropanol nitrate, peroxybutyl nitrate, all are formed due to NO2 only. So that's why NO2 estimation is important. Let us try one question. This is also common kind of question. And most of NOx emitted from automobiles and industry. Most of NOx emissions are from automobiles and industrial operations. Even carbon monoxide also automobiles only. Most of CO released from automobiles, petrol, gasoline engines, petrol engines, etc. That's why people are asking us to switch over to electric vehicles. The reason is this only. NOx emission will be very, very high from automobiles. Come on, this is ESE question, very simple question. Just by adjusting the unit you can work out. Question number 8. So mainly numericals you have to focus. This is ESE question. Without calculator you can manage. Assuming annual travel for each vehicle to be 20,000 kilometers. What is the quantity of NOx produced from 50,000 vehicles with emission rate of 2 grams per kilometer per vehicle. Come on, work out. These are question. Just a unit adjustment. Options are given to you, but I have not given options to you. He has given A 1800 tons, B 1900 tons, C 2000 tons, D 2100 tons. And how to find out? So NOx emission, total NOx emission per year, you have been asked to find out. So rate of emission, number of vehicles, and distance traveled per annum. So 2 grams 2 grams per vehicle per kilometer, or 2 grams per kilometer per vehicle. Into 50,000 vehicles. Average they are traveling 20,000 kilometers. These kilometers, these vehicles. So they cancel out. Vehicle, vehicle, kilometer, kilometer. So left with grams. But you have to convert this into tons. How to convert grams into tons? Into 1 by 1000, then become kilograms. One more 1 by 1000, it become tons. Come on, work out. Tons unit system, how to work out? 2000, na? Okay. That was the answer. So these are the major air pollutants of concern. This is the first part of air pollution. Second part of air pollution deal with the atmosphere. It's called meteorology. Meteorology means study of atmosphere. Study of atmosphere. So the concentration of air pollutants in atmosphere depends on atmospheric conditions. What is that atmosphere? Concentration of air pollutants released into atmosphere depends on dilution and dispersion. Dilution means mixing, dispersion means spread. Dispersion that occur in atmosphere. Diluting with the air and spread in a wide area. In air. Mixing with air and spread on a wide area. Reduces concentration. Somebody smokes cigarette, that's mean cigarette smoke, you see, after some time it disappears. What happens? It is there, but it is not, it is diluted and dispersed. Therefore it is not visible to you. Small amount would be there, but if there is no dilution dispersion occur, then smoke concentrate at one place, exposure will be more, concentration will be more. So dispersion, dilution that occur in atmosphere. So dispersion and dilution that occur in atmosphere depends on atmospheric stability or stability of atmosphere. So this is what we need to find out. When to release, how much to release, when to stop releasing, how to hold it, this and all we need to work out. Atmospheric stability is measured by weather parameters. Measure of atmospheric stability. weather parameters. They are: one, temperature, very important one. Second is winds. Third one is pressure, atmospheric pressure. That's all. So main is temperature. What is temperature? Temperature is the measure of heat energy. So atmosphere is heated up, then more dilution, more dispersion occur. Heat energy. The vertical transport, vertical movement of air pollutants in atmosphere depends on vertical movement or transport. Depends on what? Depends on temperature profile of vertical atmosphere. What altitude these air pollutants rise in atmosphere, that depends on temperature. So if we see the temperature profile of vertical atmosphere, that is not constant, it keep on changes. So vertical atmosphere temperature change, in vertical atmosphere temperature changes with altitude. Temperature changes with the altitude. Okay. So change in temperature with the increase in altitude is known as lapse rate. So that is what we need to measure. Change in temperature with increase in altitude. Technically it is known as lapse rate. Okay, this is what you need to measure. So lapse rate means mathematically it is dt by dz. Okay. So vertical atmosphere is a temperature profile keep on changes. But we consider only troposphere because we live there. Beyond troposphere we don't have any other business. So whatever we talk, whatever we discuss in air pollution studies, it is only troposphere. How troposphere temperature profile changes? Decreases with altitude. So slope of this profile is called lapse rate. So this is d z, this is dt. So dt by dz is known as lapse rate. Clear now? But there are two types of lapse rates to confuse us. If it's only one type, no problem, would have taken comfortably. But there are two types of lapse rates. There are two types of lapse rate. One is called adiabatic lapse rate. In shortcut we write it as ALR. Second one is called environmental lapse rate. In shortcut we write it as ELR. So the difference between this ELR and ALR gives rise to vertical movement of air pollutants in atmosphere. Okay? Adiabatic lapse rate is ALR, environmental lapse rate is ELR. So normally ALR means ALR is always constant. Some people also call it as dry adiabatic lapse rate. Both are same only. So adiabatic lapse rate or dry adiabatic lapse rate, both same only. Some people call it as dry adiabatic lapse rate, DALR they write. Nothing wrong, both are same. So when temperature decreases minus 9.8 degrees Celsius for every 1 kilometer increase in altitude. When temperature decreases minus 9.8 degrees Celsius for every 1 kilometer increase in altitude, then the lapse rate is known as adiabatic lapse rate. Which always remain constant, which is always constant, it doesn't change. So adiabatic lapse rate is always constant. Adiabatic lapse rate is equal to dt by dz, which is equal to minus 9.8 degrees Celsius. Minus sign indicates decrease in temperature for every kilometer increase. So for our comfort and convenience, what we do? This ALR we take it as minus 9.8 degrees Celsius per 1000 meters. Kilometer means 1000 meters. Per 100 meters, it is 0.98 degrees Celsius per 100 meters. For our comfort and convenience, what we do? We round it as 1 degree Celsius per 100 meters. Easy, no? Round it to 1 degree. So ALR means always the dt by dz value is how much? Minus 1 degree Celsius per 100 meters or 9.8 degrees Celsius per kilometer. Understood? Okay, all right. It is approximated as 1 degree Celsius per 100 meters. Approximated. So it's always constant. The point which you need to remember is any rising warm air parcel in atmosphere always follow adiabatic lapse rate. Any rising warm air parcel in atmosphere always follow adiabatic lapse rate. Either it is a smoke of a stack, or it is a smoke of a cigarette, or it is a smoke from exhaust of the automobile, whatever it may be. Any warm air parcel that rises, when it rises, it follow adiabatic lapse rate. Any warm air parcel in atmosphere always follow adiabatic lapse rate. Remember. Okay, today I'll stop here. Then tomorrow we'll see about environmental lapse rate and numericals related to ALR and ELR. They are very, very important for exam. Civil engineers, first time they are studying about meteorology, therefore not having good idea. But anyway, they are simple only. Easily you can work it out the things. So today I'll stop here. So Unacademy offering 23% flat discount on every subscription on the eve of New Year. And if you are willing, anybody willing to join, then better make use of this offer. Okay. So you can use my code GATE Civil. Then Unacademy also conducting mock exams at free of cost. Enroll for this and take mock exam. They will announce the all India ranks. Okay. For this also you can use my code GATE Civil. What to do? We need to advertise like a salesman. That is a policy. Tomorrow we'll continue with air pollution topic. Okay. Tomorrow also, if possible, I'll take 2 sessions. So one session I'll complete your syllabus, air pollution topic tomorrow. Maybe I'll take 4 p.m. to 6 p.m. one session. Okay. So air pollution, remaining portion of air pollution. Then, if possible, I'll cover noise pollution for ESE people. Some numericals are there. Or if we ignore ESE, then we can complete that one. If possible, I'll cover noise pollution, if time permits me. Then from 8 p.m. to 10 p.m. we'll take micro revision. Micro revision of this environment engineering class. Fast we can revise in 1 or 2 sessions tomorrow. Tomorrow and day after tomorrow we'll keep for revision. Then by 31st we'll complete, including revision, micro revision. Okay? Do attend the classes, don't miss. Okay then, good night all of you. Thank you very much.